Do you remember how I define an angle in Emaths? With the x and y axis. Where did I start from? From which axis did I start from? X-axis. From the positive x-axis. Okay, I start from here. And what direction do I go? Anti-clockwise. For some reason, we always go anti-clockwise. Okay, so for example, this is an angle. Over here, let's call this theta. So this y and x. If I were to draw a dotted line down, okay, perpendicular to it, I will be able to find my Trigo ratios, right? Depending on the x coordinate and the y coordinate. Right? So let's pretend that this is 3 and let's pretend that this is 5. What is, okay, let's change this. Let's pretend it is 4. Okay, what is tangent theta in this case equal to? Tangent theta, come on, hurry up, hurry up. What is tangent theta? 4 over 3, why are you also unsure? Huh? Okay, what is sine theta? Sine, how much is it? 4 over? Over? What, R? R is it? What's R? 5? How do you get 5? Pythagoras theorem. So we need to remember 3 squared plus 4 squared is 5 squared. Okay, so this is 4 over 5. What about cosine theta? 3 over 5. Oh? Okay, so this is a quick recap for our, which quadrant is this? This is quadrant number 1. This is quadrant number 2. Quadrant 3 and quadrant 4. For Emaths, we only concern about quadrant 1 and 2. For Amaths, we do all. Okay, so now besides our angle being in quadrant 1, we can also have our angle in quadrant number 2. So an example of an angle in quadrant number 2 could look like this. Theta number 2. Okay, then I can have a quadrant, an angle in quadrant 3. This will be theta 3. And finally, I have an angle in quadrant number 4. This is theta number 4. Can? Since I've got angles like this, and I call these positive angles. Can you make a guess? How do I draw a negative angle? All my positive angles look like this. So what exactly does a negative angle look like? Opposite? What do you mean by opposite? Left, right, up, down? What? So we are using anti-clockwise so far, right? So the other direction must be clockwise. So as in our textbook, page 230, if I go clockwise, for example like this, still starting from the positive x-axis, this is now a negative angle. In this case, theta is negative. Can? Just like that. So let us do some, let's look at some examples at the bottom of 230 for positive angles, and over here we've got alpha. Okay. The first one, the word alpha appears again, but they have no relationship with our what we used for alpha earlier this year. So this angle 60 degrees. Okay. This angle 60 degrees, starting from the positive x-axis, go anti-clockwise. Then I write down also alpha equals to 60 degrees. And this alpha, I call it the basic angle. This is known as the basic angle, otherwise known as the reference angle. It's just a name. But there are some restrictions to it. It must be acute. Okay, this is acute angle. So this is what I have in quadrant number 1. In quadrant number 2, it looks like this, right? This is theta, right? So theta could very well be, for example, 120 degrees. Then what is alpha? Alpha is the basic angle. It must be acute. Okay? So let me show you the definition for our basic angle now. The basic angle is the angle formed between x-axis and the line. Okay, so for our first quadrant, from our x-axis and the line, okay, this is my alpha in red. For the second quadrant, from the x-axis and the line, so I've got my x-axis and I've got a line. Where is the acute angle? This one? Okay, it must be acute. So what is this value? Alpha equals to? How much? 180 minus 120, we get 60 degrees. Okay, if this theta is equal to 130 degrees, what is my alpha? How much? 50 degrees. Very good. So now we have covered first and second quadrant already. Let's go on to the third quadrant. So this theta, give me a possible value for this angle. How can this be 45? How can this be 180? 220. Okay, fine. 220 degrees. So where is my alpha? Where's my basic angle? Okay, I give you an option. This is option A. This is option B. This is option C. And this is option D. A, B, C, or D? Acute is formed between the x-axis and the line. Which one is it? Which one is it? I don't have same answer, no. Who thinks it's A? Okay, can't be A lah. B? Who thinks it's B? Okay, who thinks it is C? Who thinks it is D? Okay, let's talk about the first thing. It must be acute, right? Can it be A? Can it be D? Also cannot be. So D is out. A is out. Then I say that it must be formed between the x-axis and the line. So can C be the answer? Can C be the answer? Cannot. Must be B. So B is my acute angle, my basic angle over here. What is therefore the value of alpha? Value. 40 degrees. How do you get 40? There are different ways of getting it. The most straightforward is 220 minus 180. Get it? Finally, for our fourth quadrant. Like this. So we start from a positive. This is my theta. Give me a possible value for theta. 3. Okay, so you want to try 300? Can. Where is my alpha? All of you think first before I show you the answer. Where is the basic angle? Okay, visualize it. And the answer is over here. What is the value? Okay. Now, let us go the other direction. Let's start with, let's start with the fourth quadrant. So this is what you have in red color. I will now use black color. Okay? I'm going to go, instead of anti-clockwise, I'm going to go clockwise this time. What is this angle in black? Negative 60 degrees, yes. Okay? This is the same as negative 60 degrees. What this means is that, you need to remember this, positive 300 degrees is the same as negative 60 degrees. Because they represent the same thing. They all represent a line looking like this. Okay? So take this with you first. Positive 300 degrees is the same as negative 60 degrees. What is the basic angle for this diagram? What is the basic angle? The definition doesn't change. Is it negative 60? 60. The basic angle, the reference angle, is an acute angle. Acute means it's between 0 to 90, right? So for this case, the basic angle doesn't change. It is still 60. Okay? Let's go to this case. Quadrant number 3. What is my angle in black? Where got 131? What is this angle in black? Are you sure it's 140? Negative 140 degrees. Okay, because it goes clockwise, then it is a negative. Then, because I know this is 220, then this must be 360 minus 220 must be 140. Can so far? Okay, then what is the basic angle in this question? How much? It must be acute It must make an angle with the x-axis and the line. So what is it? Still 40. Basic angle doesn't change. Now let us move on to second quadrant. What is this angle over here? Negative 2, 3, 0. What is the basic angle? It is still 50. Let's go to this case, quadrant number 1. I go from the positive, I go clockwise. How much is this angle? Negative 300. Simple? Okay. And your textbook very kindly told you that hey, there is a serious misconception for students. Some people think that this is the basic angle. Is this the basic angle? No. Where is the basic angle? X-axis and the line. So this is wrong. This must be my basic angle. Okay? Okay. Yes. So earlier on, I mentioned that positive 300 degrees. Okay, nobody writes a plus in front of the 300, right? If it is positive. So I say that this is the same as negative 60 degrees. Am I right? And the diagram to show this is this, where I have 300 degrees and negative 60 degrees. Am I right? Are there any other angles that can represent this line, this slanted line? Are there any other angles? So I am saying that for this line in yellow, I can represent it with positive 300 degrees, I can represent it with negative 60 degrees. Any other angles? Huh?
Negative 300 degrees, positive 60.
Negative 300 will be over here already. Sorry, negative 300 is over here. What else could it be? Okay, you can choose radian, you can choose to express it in radian, but there are more answers. Why 120? You mean this part is 120, is it? No, but it doesn't represent. I must always start from this positive side of the x-axis. You cannot start anywhere else. So I show you. Look, I always start from the positive x-axis. How much is this angle right now? How much is it now? How much now? How about now? How about now? How much is it? 360 plus 90, 450. Okay, continue.
540.
Then? Confirm, Until here is 630, right? Is it not? I'm not counting already. Okay, then I continue a bit more. Okay, hang on. How much? This is 60, right? So this must be 30, right?
660.
So this is 660.
Yes.
So we go all the way over here. This is 660. Does it represent the same thing? Can you now see that there are so many possible answers? Yes? Oh, sorry. Okay, so this line can also be represented by 300 degrees, negative 60 degrees, and 660 degrees. Can you now give me another answer? There are more. Plus another 360. So how much do we get? Plus 360, we get 1020. Any more? How much? 1380. Any more? Do you see the pattern? What did I keep doing? I go one more cycle plus 360. Go one more cycle plus 360. Can I go the other direction? Negative 440. Okay. So from negative 60 degrees, I also get minus 360, right? Right? So minus 360 degrees, I get negative 420 degrees. In fact, if I try from this 300 degrees, if I take 300 degrees, I minus 360 degrees, what do I get? You see, they're the same. Get it? All okay? Therefore, can you now try keying in your calculator sine 30, sine 300 degrees.
Negative number.
What is it?
Negative 0.8660.
Okay, negative 0.866, blah, 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 right? How much is this actually?
Negative
Practice. What is 0.866? Okay, so this is negative root 3 over 2. Okay, now I want you to try sine, just though we say all these are the same, right? Let's try lah. Try sine 660 degrees. What do you get? Same thing. You can try for any of them, you will realize that they're all the same. Can? So we don't need to go through, basically all this is found in page 231 and 232. Okay? All the going round and round, it's just repetitive. So let us move on to 8.3 on Trigo ratio of general angles. Do you remember we mentioned before that sine 180 degrees minus theta equals to sine theta? Remember this? Do you remember how to prove it?
No.
Do you know this relationship? You know, right? But do you know how to derive it? You can watch the video again, or I can just tell you now. In our circle over here, we have angles always starting from the positive x-axis. If I have an angle like this, okay, let's call this theta. And this has a x1 over here, y1. So the coordinates are x1 and y1. This is theta. Where is 180 minus theta? Where is 180 minus theta? This is 180 minus theta, isn't it? Yeah. But this red angle over here did not start from the positive x-axis, isn't it? Where exactly is 180 minus theta starting from the positive x-axis? We need to draw a symmetrical line first. We need to draw a symmetrical line across. So on this side, this coordinate, we'll figure it out later. This being theta, okay, they are symmetrical. This being theta, so this angle must be 180 degrees minus theta, right? Okay, now tell me what are the coordinates over here. If it is symmetrical, what is this value? x1, is it? No, it is negative x1. What about the y coordinate? Okay, so here we have negative x1, comma y1. Alright? So basically, if I have sine theta, what is the formula for sine? What over what? You better not tell me opposite over hypotenuse, huh? What over what? x1 over, sine are you sure it's x1? x1 or y1? y1 divided by r. Do I have r over here? Don't have. You can also call it square root x1 square plus y1 square, right? Pythagoras, we did that earlier on. 3 square, 4 square, 5 square. So for simplicity, let us call it r first. Okay? Now we have our sine theta, 180 minus theta. Sine 180 minus theta. What is the numerator? What is in our numerator? Sine 180 minus theta. X or y first? Come on. Sine. We have we define sine as y over r in Emaths. Regardless of the angle, it is always y over r for sine. For cosine, it will be x over r. For tangent, it will be y over x. Remember? Okay? So in this case, what is sine 180 degrees minus theta? It is still y over r, but what is the value for y? Is it y1? Is it y1? 180 degrees minus theta? Does it have also y1? Yes, it is also y1. Therefore, we have y1 over r. and we see that since these two are the same, therefore sine theta equals to sine 180 degrees minus theta. This is how we derived it. Can? Let us do the same for cosine. Cosine theta equals to, according to the diagram, is it x or y? Cosine. X. x1 over r. Okay? What about cosine 180 degrees minus r? Minus theta. Negative x1 over r. Are these two the same? Are they the same? No, they are not the same. They are different because there's a negative sign. That is why we say that cosine theta equals to, then I leave a blank first, cosine 180 degrees minus theta. They are not the same. I need to put a negative sign to make them the same. That is found in the bottom of page 232. And we stop here for E-maths, remember? What about A-maths? Can we continue with another trigo identity? With another trigo? Tangent, isn't it? Let's find out what tangent gives us. Okay, tangent theta. What is tangent theta? y1 over x1. Okay, what about tangent 180 degrees minus theta? Negative. Are you sure it's negative? Look, what is in the numerator? It is still y, isn't it? Is the y value the same? So it is still y1 ma? Okay, so this is y1 divided by x value. What is the x value now? Negative x1. Therefore, this tells us that tangent theta, is it the same as tangent 180 minus theta? They are not the same. What must I do to make them the same? That's it. You can try your calculator. With your partner, somebody try tangent, what number you want? 20 degrees. The other person tries negative tangent 160 degrees. Do you get the same answer? Same answer? Yeah, so this is the relationship. Okay, next part. Again on our circle. Okay. Class, all pay attention. This is so important, I cannot overemphasize it. The first quadrant over here, I've got x1, y1. Okay. This circle has a radius r, or whatever it is a positive number. Okay. The angle looks like this, theta. Now, tell me, x1, is it positive or negative? x1, positive. y1, positive. Because x1 is here, right? This is x1, this is y1. Okay? What about x2? Positive or negative? Negative. Y2? Positive. X3? Negative. Y3? Negative. X4? Positive. Y4? Negative. Okay, good. We are all able to do this. There is no other answer. Let us look at what happens for the first quadrant. For sine theta. Okay? Wait, no, before I write this, let's just write down the general form. Sine theta equals to x or y over r. X or y? X or y? Y over r. Cosine theta equals to x over r. Tangent theta? Y over x. Okay, let's talk about the first quadrant now. Watch carefully. Actually, we've done this before, first quadrant. Okay, so sine theta equals to y over x, right? So numerator is positive or negative? Positive. Positive. Okay, I'll just put it like this. Radius. Radius must be positive, no choice, right? Because it's a length. So it is positive. Sine theta is positive. Let's do the same for cosine theta. Positive or negative answer? Positive over positive, so we get positive. Tangent theta. Positive over positive gives me positive. So, in the first quadrant, sine, cosine, tangent, all positive. Second quadrant, okay, I think you're bored, right? Sine, theta. Okay, come, tell me the answer. What is the numerator, positive or negative? Okay, positive. Okay, so this is still positive, still very boring. Cosine, theta. You are. Wait. Okay, tangent theta. 1 over what? Positive over? Over? Negative. So it is negative. So, okay, now let me highlight. Okay, I am now going to highlight all the positive ones. Positive, positive, positive. So sine, cosine, tangent. On this side, which one is positive? Only sine. Let's talk about the third quadrant. This is where we start Emax. First, Emax we start at first two quadrant only. Now, our quadrant number 3. What color should I use? Okay, let's use gray color. Hopefully you can see that. Sine, theta. Wait, what do we have? Negative over? Over positive. Because the radius is length, it must be positive. So this is negative. Cosine theta? Negative over positive. So negative. What about tangent theta? Negative over? So we get? Okay, right now in the third quadrant, who is positive? So we've got in quadrant 1, all positive. Quadrant 2, only sine positive. Quadrant 3, only tangent positive. Can you guess what's going to happen in quadrant 4? Who is positive in quadrant 4? Sine. Let us verify. Okay, so sine theta is, what do you have? Negative over? Answer? Okay, cosine. Positive divided by? Answer? Tangent theta? Are you sure or not? Okay, you're correct. Okay, so we've got all over here, all positive. In the second quadrant, I've got sine positive. In the third quadrant, I've got tangent, and I've got cosine over here. So, why did I write this down? Because it is useful for you to memorize, to know what quadrant has which Trigo ratio as positive. Otherwise, if you don't memorize, you need to go and do all these things out, which is not too bad also, right? So to memorize. Adventure survival. Okay, yeah, you can. Okay, we will start from the first quadrant. A, then followed by S, T, and C. So yeah, ASTC students, I didn't think of that, but yeah, you're right, Adventure survival training camp. So for the majority of us, we can remember it like this. All science teachers are cool. No. I'm a science teacher also. Okay, so whatever it is, all science teacher crazy, all students, whatever, just memorize it. All students take chemistry, all students take chemistry, right? Whatever helps you. Since cosine theta is negative, it cannot be here. Cosine theta is negative, cannot be here. It must be either quadrant 2 or quadrant 3. Okay, either or. If you don't believe, you take your calculator, just go and key in cosine, something that is more than 90, less than 2 270. You will get a quadrant 2 or quadrant 3 and you will get a negative value. Okay? Then the question is, hey, I cannot have two of these quadrants, ma. Where exactly is theta? Then we read on. They say that tangent theta is less than 0. Once again, the same question, where is theta? Tangent theta is less than 0. ASTC. Can theta be in the first quadrant? No. No, cannot be because it's all positive, right? Can theta be in the second quadrant? Yes. Can theta be in the third quadrant? No. Can it be in the fourth quadrant? Yes. So in summary, where is theta? Quadrant 1, quadrant 2, quadrant 3 or quadrant 4? Quadrant 2. Because it appears twice. Quadrant 2 is the only place that I can find theta such that cosine theta is negative, tangent theta is also negative. No other quadrants. Okay? So here we know that theta is inside second quadrant. So I can sketch already. So this is, let me just write down, quadrant 2 and quadrant 4. So I'll circle it. Okay, so this is how I decide it is in quadrant 2. I want to be able to solve for sine theta and tangent theta. So I'll sketch it out. We know it is in the second quadrant. All sketch with me. Horizontal, vertical axis. Second quadrant, draw a line across like that. Simple. Okay? Where is theta? Where must it start from? Positive x. Go anti-clockwise. This is theta. Okay? Simple so far? Now I want you to always drop a dotted line down to the x-axis because I still require to find my right angle triangle. Standard. Okay? So this is obviously my right angle. And where is my basic angle? Where's my alpha? Yeah, alpha is the basic angle, it's over here. So, okay? 180 minus theta. Yeah, that is my alpha over here. Now, based on the first equation, cosine theta is negative 5 over 13. Okay? And keeping in mind that earlier on we said cosine theta equals to, is it x or y over r? Which one is it, x or y? Cosine. Keep practicing. X or y? X. Adjacent. Okay, x over r. So in this case, if cosine theta gives me a fraction which is 5 over 13, but negative, where do you think 5 units are? Negative 5. Okay, I give you option. Is it over here? This is option number 1. Is it here? 2 or 3? 1 lah. Okay, adjacent ma. So this will be my 5 units. Okay? I write units because for the sides of a triangle, you can measure with a ruler, right? The sides of a triangle can be measured with a ruler. So the magnitude is 5 units. But can you tell me what is the coordinate over here? Okay, this is the coordinate. Now I'm talking about coordinate, it is negative 5. You must know the difference between length and coordinate. Okay? So I have already settled the numerator. I know that the negative sign belongs to the 5 because it is in the second quadrant. So where is my value 13? Is it option number 2 or 3? Who thinks it's 2? Raise your hand. Who thinks it's 3? Okay. 2 will refer to the opposite side. Right? 2 over here, it came from the y value. This opposite side. Therefore, this answer should be 3. This value over here, 13 units. 10. We need to remember cosine theta is x over r, where r is the radius. We're going to draw a circle like this. Therefore, the radius is 13. Now with this, can you tell me the y value over here? How do you know 12 so fast? 13 squared minus 5 squared is 144 divided square root 8, you get 12. Is it positive or negative 12? Positive. Why? Why can't it be negative? Because it's above the x-axis. So we've got 12 units over here. And the y value will be 12. With this, can I now find out what is sine theta? Sine theta, how much is it? So we need to remember sine theta is y over r. So what is y? 12. Positive or negative? Positive. Yeah, it is exactly positive 12. What is the radius? Done. So sine theta will be 12 over 13, provided that cosine theta is negative 5 over 13 and tangent theta is less than 0. Okay? Now we need to find tangent theta equals to, what is it? Tangent theta. The question asks us find tangent theta also.
Negative 12 over 5.
Negative 12 over 5. Okay, opposite over adjacent. So strictly speaking, this negative sign belongs to the 12 or the 5? It belongs to the 5. But I can just, we normally write it this way, okay? Yeah, it's negative anyway. So take a step back, look at this question again. The question told us that cosine theta is negative 5 over 13. They also, and then we know that it could be in quadrant 2, it could be in quadrant number 3. But they also tell us another piece of information that is theta, tangent theta is less than 0. Then we shortlist it to theta, quadrant 2 and quadrant 4. The overlapping quadrant must be where it is found, and that is quadrant number 2. From there, we draw the triangle, find the hypotenuse, find the y coordinate, write down the two trigo ratios for sine theta and tangent theta. Okay? In our Emaths, if you get this question, sine theta is negative 5 over 13. Ask you to find sine theta and tangent theta, what will you do? Emaths, no? Emaths I didn't ask you to draw. In Emaths, you just take theta equals to cosine inverse negative 5 over 13, right? Then you get a value, right? That is an angle. Then you find sine theta equals to sine, then bracket, cosine inverse negative 5 over 13. And you get the answer. So key in this in your calculator right now.